mathematicians, it's Justin again. I'm in my backyard again watching the new plants in my garden grow. You did such a great job helping me with my garden, I think we're ready for something even bigger. It's time to build a pool. Think of how fun that'll be. I could have my friends over for pool parties in the summer. I can't wait. I have space for a square-shaped pool with an area of 50 square yards. For my garden, we were able to take the square root of the area to find the length of the sides. You think you can use the same strategy to find the side lengths of a pool that covers 50 square yards? To take the square root of 50, we need to find a number that squares to equal 50. Can you think of one? 7 squared is 49, but that's just a little too small. And the next number I can square is 8, but 8 squared is 64, and that's just too big. There aren't any integers between 7 and 8, so what does that mean? Well, since there isn't an integer I can square to equal 50, it means 50 is not a perfect square. Hang on though, there aren't any integers between 7 and 8, but are there other numbers between 7 and 8? Yeah, numbers like 7.5, 7 2/3, 7.1, 7.9. Those are all between 7 and 8. Maybe the square root of 50 is one of those numbers. I think I've seen the radical symbol on my calculator. Let me see what happens when I type in square root of 50. Whoa, that's a lot of digits. What do we call decimal numbers like this that keep going on forever without repeating a pattern? Irrational numbers. Even though the number looks a little crazy, the square root of 50 is a number, and it's just a little bigger than 7. That's between 7 and 8, just like we thought. So my pool with an area of 50 square yards will have side lengths of about 7.07 yards. That's something we can work with. I'll go write that down so I can remember it for later when I start working on my pool. To better understand irrational numbers, we can try thinking about their counterpart, rational numbers. Do you remember what rational numbers are? Yeah, rational numbers are numbers that can be written as fractions. And how are irrational numbers related to rational numbers? Irrational means not rational. So, irrational numbers are those that cannot be written as fractions. Decimals that never end and don't repeat a pattern, like the decimal we got for the square root of 50, can't be written as fractions. That's why they're irrational. I wonder whether other square roots can be irrational too. Let's try a few more numbers to see whether we can find a pattern. Let's check the square root of 2. That's 1.4142, and it keeps going. How about the square root of 30? That's 5.4772, and it keeps going. Are these irrational numbers too? They are, because the decimals never end and don't repeat. Wow, the square roots of 2, 30, and 50 were all irrational numbers. Huh. We know it's possible to get integer square roots, so what could be happening to cause all the square roots we tried today to be irrational? Pause the video to write down your thoughts in your guided notes. Oh, these are irrational numbers because the numbers under the radical aren't perfect squares. Let's add this to what we already know about irrational numbers. The square root of any natural number that's not a perfect square is an irrational number. That's because they all result in decimals that don't end and don't repeat. Let's practice identifying some irrational numbers. Pause the video to circle the irrational numbers in this list in your guided notes. Looks like we only have one irrational number here, 3.8230. The ... means the number keeps going on forever, and there's no repeating pattern. That's what makes it irrational. 0.1212 also has the ... But since there's a pattern repeating the 1 and 2, it's not an irrational number. 5/7 is not irrational because it's written as a fraction, and 5 and 0.25 are not irrational because the numbers don't go on forever. Here's a new list of numbers, this time with square roots. Pause the video here to circle the irrational numbers from this list in your guided notes. Which numbers here are perfect squares? 36 and 4 are perfect squares. The square root of 36 equals 6, and the negative square root of 4 is -2. Those are not irrational numbers. On the other hand, 3 is not a perfect square, which means that the square root of 3 is an irrational number. And since 75 isn't a perfect square, the negative square root of 75 is also an irrational number. Don't let the negative sign there throw you off, though. It just means that it's a negative decimal number that never ends or repeats. Now that we've had some practice with irrational numbers, let's think about all the different types of numbers we've learned about. They're called real numbers. Real numbers are either rational or irrational. As we've learned before, some rational numbers can also be categorized as integers, whole numbers, or natural numbers. Let's use that diagram to try one more example. Classify each number as a natural number, a whole number, an integer, a rational number, or an irrational number by writing it in the most specific category on the diagram. For example, 0 is best classified as a whole number. 0, like all whole numbers, is also an integer and rational number, but whole numbers is the most specific category that it belongs to. Go ahead and pause the video to classify this list of numbers in your guided notes. The square root of 5 is an irrational number because 5 is not a perfect square. This would result in a decimal that doesn't end or repeat. 49 is a perfect square, so the negative square root of 49 is -7. That's an integer. 81 is also a perfect square, so the principal square root of 81 is 9, a natural number. The little bar in 1.36 means the digits 3 and 6 repeat forever, like this. Since there's a repeating pattern, this is a rational number. The ... after 6.3762 tells us this number also keeps going forever. There's no repeating pattern, though, so it's an irrational number. The decimal 1.7 stops, which means it's a rational number. And finally, 3/50ths is a fraction, so it's also a rational number. Wow, check that out. Each of the square roots ended up being classified differently. I'm glad I stopped to think about what each of those values meant instead of jumping to any incorrect conclusion. We've seen a lot of different types of numbers today, and numbers in many different forms. For decimal numbers, remember to look for numbers that don't end and don't repeat. That's how you know those are irrational. And for square roots, make sure to check whether the number inside the radical is a perfect square. Only the ones with non-perfect squares are irrational. And thanks for your help with my pool today. I feel so much better knowing that the length of the sides of my pool is actually a number, even though it's a different kind of number. While I daydream about summer pool parties, go ahead and finish up your guided notes, then complete levels 1 and 2 of the online practice before doing the number classification quest activity in the PDF. Until next time, keep questioning, keep calculating, and remember, in math, sometimes it's okay to be irrational. See you next time.